This video marks the beginning of the series Creating the Catcher Game. So as you can see, we're going to be constructing something where objects are falling on screen, and we will endeavor to catch those objects as they fall. As we catch them, we'll see that we get a score that is progressively going up. Currently, the objects, when they're caught, are put at the top of the screen so we can verify indeed that catching is happening. So it gives us some goal or understanding of what we're trying to do. So we want the objects to be able to fall, we want to be able to catch them, we need to release them in a controlled manner. To begin creating the catcher game, what we are going to do is start out with a basic project. So we'll have our standard two functions that we work with. So void setup. And with this, we will just go for a standard size on this. And I always like to hard code in what is going to be the background color in the beginning. And now void draw as well. Always making sure to put in our closing curly braces. And I am going to just put comments up here, so I know who it belongs to. So this is now the start. If I run my program, we'll verify now we have catcher running. It's not a lot to see yet because we haven't made anything of substance. I'm going to add an additional class in here. The class I'm going to do will be for the catcher object. And in the beginning, what we're going to do is just use simple round objects as our beginning, and then we will create more complex objects, eventually replacing those code-based objects with images. So we will bring images into our projects and really take it up quite a few notches. So the first thing I want to do is to make my catcher class. And to create the catcher class, it's the same as when we make any other class. So I have my properties, my constructor, and my methods. So every class follows this, not every class, but every visual class is going to follow these same kind of structures as part of it. So what I want to do is set up my X, and we can put all of these float X, semicolon float Y, or we can put a number of these things all on the same line if we want. And I can, if they're all of the same type, I can put them all on one line like that. Now I can create my constructor for this, and in the constructor I will start my catcher out at the center of the stage, and so we use height and width set at that. And let's just try, we'll start out, we can figure out size as we want to do it later, but we have width and height as we work with this. So I'm going to just start out and give it a, not X again, width X, W, they kind of look alike, so why not? Now if you don't do good indents and spaces and other things around it, always remember you can clean up your code by going down under Edit and choosing Auto Format, which is also Command T. That cleans all of it up, so it helps make our code look a little bit better. Now we have our two methods that we add to almost every visual class as we work with them. And that would be void update and void display. So update, we update any changing properties of the object, and display is where we put the information on how we want to draw that object onto the screen. Now what's really nice in processing, we have access to the mouse position on screen. And the property for doing that is mouse X, and surprisingly enough, mouse Y is the property to give us access to the Y position of it. Now I'm going to choose a color. Right now I'll just fill it with white. I know it's boring, but we'll be choosing better colors down the road. And now I'm going to draw this object here. So we could use ellipse, we could use circle, doesn't really matter which one we use because it's a round object. So if we want to use circle instead of ellipse, since we're kind of drawing circles, so X, Y, and then our width for that circle, so that we can draw it on screen. Now we have the class completed. Good idea to save. And I want to add an instance of that class. So we reference what type of object we're adding, and then I will have my variable name that I'm working with. And I will say C is going to be equal to a new catcher, just like that. And now that created a new catcher, and now I can say C.update and C.display. If we give this a quick run, we'll see that it's working. It's kind of drawing a continual path because we're not clearing the background between each frame. So if we want to do that, we need to specify at the beginning of each draw cycle that we wish to clear what we are seeing on our screen. And we can do that by putting in a method. Now what I would like to do as part of this is to separate this logic out. And this is because as our programs grow more complex, if we embody or encode things into separate methods or functions, it helps to organize our code to make it more understandable. So I'm just going to call clear background. Now that seems like a logical name for something. The reality is that method doesn't exist. This will be one that we are creating. So we get to create what that method is. And I can just simply say void clear background and a couple curly braces, close it out. Now inside this, what I can do is I can choose a fill color that I'm filling it with. Now I could just as easily say background, and I could say 128, it just repeats what's there. But we're going to do things a little bit different because, well, we can. Now if I look at it, we see it's following. Takes it a moment sometimes to catch up to a really fast move. If I go outside, pop over to the other side, we can see how it's responding. So that's how we could do it. But I would say if I were to fill it with the same color of the 128, gray, but I do it transparently. So I say 100 for my transparent value, remembering the value is between 0 and 255, so 128, that's why 128's middle gray. So 100 means we're a little less than 50% opacity, so we're fairly translucent. And these are all numbers you change, you play, you adjust until you find you have the result that you want inside your project. Now I'm going to draw a rectangle, and I'll start it at the top left and the top left corner, and I'll draw it the full width and the full height of the sketch. Now if I run this, what I will see is we start to get almost a trail happening as it moves. And notice we do have a black line around it. If I were to go in and inside my draw simply say no stroke like this and now run it, we'll see that now it's just white and it seems to almost have a nimbus kind of halo as it's moving. So I think that gives a nice visual. If you noticed in the video when the red drops were following, they seem to have a little red streak happening, and that's part of how that is occurring. If we change this transparency number down and further, say like 50, then when we do it, we can see where we're really getting that nice stroke trail happening as it moves through. And if you start doing it with colors and stuff, it works really nice. It gives a nice visual effect. Or you can just go back to the solid color. Does not matter to me. This is up to you as you try and customize your project. catcher's working, time to add in the drops. Now the drops are going to be pretty similar to the catcher in that they have an update, they have a display, they're drawing some stuff, but we're going to end up having to add a few extra additional methods into those so that we can do something with them. Because ultimately what we want to have happen is inside the main program will see what's happening between objects, but it won't modify individual properties of objects. Instead, what it will do, it can read them, but it doesn't set them. It will tell the class itself if it needs that object to do something, like to, say, go away because the drop has been caught. Well, it's going to tell it to be caught, and then the drop will go, oh, well, I know how to deal with my own business. Don't you, you gave me a command, I'll do it, but don't you go touching my individual properties because that makes me grouchy. So with that, we're going to add another class to the project. So add in a new tab. And remember, these are classes we're making, and by convention, classes are named with a capital letter to begin the file name. And now I can just simply say class drop, curly brace, return twice, close curly, properties, constructor, methods. So I encourage you, put those comments in. It may seem a little bit redundant, but down the road, when you're looking at your code, it will help you see how it's organized and structured, and it will make your life a little bit easier. So I would encourage you to think about that. So X, Y with height for it. We're going to have an additional property, which I could put there, but I'm just going to put it here so it stands out that it's different. Because in case you are copy-paste fiends, you may miss it. You just copied over the catcher and forget that we added in an additional value. And the speed value, the reason we're separating this out is when we're moving these drops, we don't want them all moving at the same speed because then it would look too uniform. It'd be a little bit boring and just not as much fun. And finally, we're going to set up a value, and that will be a color, because what we want to have happen is we want each of these drops to have a slightly different color down the road. In the beginning, we'll just make them the same, but eventually we'll make it so that they have some changing properties, so there's some variety, some visual excitement or interest. Now, in my drop class, constructor, now we get to populate these, and we can just choose a random value to put it on screen, so random width. So that takes the width of the sketch, which in this case is 800. I'll choose a random number between 0 and 800 and populate it with that. And we'll start Y at 0, so they start at the top of the screen. And then we'll set the width here. Make them 16 wide. Height equal to 16. They're circles, so it's the same value, but it's a good practice to get into that, because when we move away from round objects and move into rectangular objects, you may find that having been using width and height in your thinking helps you when we make that transition to non-circle based or non-round objects. So speed Y here, we're just going to start out and, well, need an equal sign, put that in. We'll make them all the same speed for now, but we could change it down the road, and we'll look at doing that. And I'm going to just start them out at red as part of it. Again, we will be changing that down the road. A good practice whenever you are developing something with code is get it working with something simple, and then once you have that done, then you can start adding in more complexity. Don't make it complex in the beginning, because if it breaks, then you don't know where you broke it. So update here. So we'll take our Y position, and we're going to set it equal to the current Y position plus speed Y. Now the thing about that is that's one way of writing it. Another way that we could write it, and we could use this notation. And both of those are performing the same operation. So we're saying take y and add to whatever the current y value is, speed y, which is pretty much the same as y is equal to y plus speed y. So we eventually want to get in the habit of using plus equals instead of the full verbose way of doing it here. So I'm going to comment that out. Now we can't have plus equals, we can have minus equals, multiply equals, and divide equals. So all of those are permissible operations that we can employ here. With some code under update, it's time to put something in display. So we're going to fill with that color value. So as we look at this, we can specify colors in lots of different manners inside of processing. So I like using RGB colors because it's tied to numbers. I can adjust those numbers very easily through code. And we reference it using the color object. So we say color and then what color we want to put into it. So now I'm going to specify what color I'm filling here. And in this one, just for kicks. So ellipse is just like drawing a circle, except that I have to specify width and height because an ellipse does not necessarily have to be round. So auto format that. And now let's go back into our catcher here. So let's start out and we'll add in one drop. Because again, remember, we keep it simple in the beginning. So we add in that drop. So we will notice it's the same as what we did before. So I can see here it's a little bit grumpy because I said C and then I said D again, or C a second time instead of saying D is equal to a new drop. So I said C is a new catcher and then C is a new drop. At that point, processing was thoroughly perplexed as to what is your intention, which is why I had underlined it in red. So now let's say, oh, look at that. See, you get that nice little streak as it falls down through the sky and it's gone. We can see the mouse is here. So the drop, while the drop is falling, the drop is not resetting itself. So if we remember how when we were bouncing objects around, we made them check for their boundaries. So that's something that we could do as well. And if our drop had significantly greater complexity to it, then we may want to create a separate check bounds method. In this case, we can include it in our update. So if y is greater than height, and we want it, so remember, round objects are drawing from their middle. So if we say greater than the height, at this point, it's only halfway off the screen. So I want it to be more than halfway off the screen. So we could add the full height value to it. If we want it to be exactly off of the screen, then we could use half of the height. So if the y is greater than the height of the sketch plus half of the height of the object, then at that point we need to do something. And what we want to do is set y equal to, and at this point, if we set y equal to 0, it will be halfway on screen. But we don't want that, so we want to do a negative h divided by 2, or we could even do a further amount, so once it goes, it disappears for a longer stretch of time. But in the meantime, let's see. All right, falling right down the side and still falling right down the side. So we have achieved looping here. So the object is looping across the screen. But we can't catch it yet. So that's the next thing that we need to do. Or we could add in a whole bunch of drops and then worry about catching. Both of those are valid next steps. We're going to now add in more than one drop. So we proved it works with a single drop. So what we want to do is add in more than one drop. So to prevent issues, I am going to comment out my existing drop information there. And now we'll say drop, and this time we're making an array, so we use square brackets. Then we say drops. Now drops is going to be equal to new, and this is where we have that redundancy in processing. So it's a new, we say what, and we're going to then specify how many drops we want to put into it. So I will just start out and say 100. The next thing I need to do is to use a loop to go and populate this array of drops with all 100 drops, getting them ready for use. So for int I is equal to 0, I is less than, and in this case, the number of drops we're working with, so we'll write in 100, I plus plus, remembering that makes I go up by 1 each time we go through this loop. So the for loop says we're going to go through this loop until this statement is no longer true, which is I is less than 100. So as long as that is true, we're going to loop through this a number of times. How many times is based on how long it takes for that condition to then no longer be true. So we start out with our counter value I equal to 0. Each time we do a loop, I is going to go up by 1. That's what the plus plus means. So the first time through, I is 0, then 1, 2, 3, 4, 99. So that's 100 times. And then at that point, after the 100th time through the loop, remember we started at 0, we add that final 1 in. I is now equal to 100. 100 is not less than 100, and that's false, so we stop going through the loop. So that's how that structure works. And then I can say drops I, so which one? Remember, we access items in an array using square brackets and their position information. So the first item in the array is at a position of 0. And it's convenient I starts at 0, so all is working out well with the universe. And then we say it's equal to a new drop. So now we've populated our entire array of drops. And then instead of telling a single drop to update and display, I'll say for int I is equal to 0, I is less than 100, I plus plus, yeah, we've seen this before, like seconds ago. A couple returns, close out my curly brace, go up arrow once, and now this is where we get to cycle through our drops here, and we can say drops square bracket I dot update. So we tell that drop to update, drops square bracket I dot display. So we're now telling each of those drops to update and display themselves on screen. So we've added quite a bit to our program from what we had before. Now let's see how this operates. And wow, all of the drops are falling. We can see how they're all falling almost as a row because we don't control their release. We're just dumping them all at one time. I think what I'm going to do to make things a little bit more interesting, we will use random. And now random allows us to say I want to choose a random number, so between 0 and something, or within a specific value. In this case, I think I'm going to try something like from 1 to 5. So now if I run this, the drops will have random speeds, and you can see as they kind of fall into the screen, after they've all been falling for a little while, now it starts to appear like a random rainstorm. So that's working better at giving us what we need, but it's not quite there because they're all falling at the same time. So what that tells us is that we need to come up with a system, a strategy, to control the release of the drops so that they don't all pound down at the same time. So what we're going to do now is worry about how can we get the drops to fall in a better pattern so they don't all start spamming at the same time like that, because it's a pretty ugly beginning. Once they're rolling, this isn't bad, but we need to work with that. And to do that, what we are going to do is we're going to construct a timer object. So this timer is a way that we're going to be able to then tell the drops, hey, I want you to fall at a certain time. I don't want all of you coming down at the same time. So to accomplish that, we will create a new class, and this will be our timer. Now, as I said, display object classes will have similar methods of update and display. This timer is a utility class, so it's going to have different methods. So class timer, curly brace, couple returns, close curly, up arrow. So we'll have our properties, we'll have our constructor, and we'll have our methods. So the same as everything else there. Now, so what we're going to do is we need a couple variables that we're going to work with here. Start time, we'll define that in the constructor. And then we're going to have an interval. The interval is how frequently we want this to run. And that interval is something that we will set in the constructor. So this is where we're going to pass a value into the constructor. So we have to tell it what type of value it's expecting. So I'm naming this time interval right here. Couple curlies, up arrow. And now we'll tell the class's internal value of interval to be equal to this time interval that we're passing into it. And the reason that we do it this way and don't just simply, not timer interval. I'm like, why is it red? Time interval. I mean, timer interval would work as well as a name. I mean, we could do that. But what we're doing is this timer class, we can now use it. We can make a countdown timer. We can make a game timer that, say, counts how long the game is playing. We can control how frequently drops are falling with a drop timer. So we can set up multiple timers because they may be at different durations, because a countdown timer is probably going to be working on seconds. A game timer could be seconds or even milliseconds, depending on how much detail we want to show. The drop timer is going to be some fraction of a second because we don't want it to be a whole second between drops, but we also don't know exactly what that value is. So we want to be able to just pass a value in. If it's not quite right, pass in a different value. So we make this utility class, and we'll be able to use this now in any project going forward. We just put a copy of this file, this timer class file, the .pd file, into whatever other project we're working on, and we now have access to the timer, so we don't have to retype code for it again. Now, most timers, we need to be able to say, hey, I want you to start at a particular time. So we give it a start method. And now we will say start time, that property up there, is going to be equal to the millis. And now what this is this is the time that has been running since this programmer's sketch was told to run. So every time we say go, it sets the start time equal to whatever that fraction of milliseconds is. And we're going to create a method. Notice it doesn't say void, it says Boolean. And this is where the timer is going to return a value. And the value it will return is whether it is done. So it's either going to return true or it's going to return false. So that is what we will put into it. So int, and now this is going to be a variable that exists only inside these curly braces right here inside of complete. We say int elapsed time is going to be equal to the current time. Current time is millis. Current time is what time is it now, and we subtract from that what time we started the program. So let's say we start the program at 0, and then 5 seconds in we say, hey, how much time has elapsed? So millis would return 5 seconds, and if start time was at the very beginning, then it'd return 5. That's our elapsed time. But now if we ask the same question and the program's been running for 23 seconds, and the timer was started at 13 seconds, it would be an elapsed time of 10 seconds. So the values are always going to be changing. Now, it's never going to be nice even numbers because it's measuring it in thousandths of a second. So that's a little bit different than my large number math I just did instead of fractional time. So if our elapsed time is greater than the interval, how long we want this timer to run, that would signify that return true. Wow, fingers are losing it badly there. So if elapsed time is greater, so meaning more time has passed than the time we want this to run, and because this is measured in milliseconds, so that's just 1,000th of a second, then we'll return true. Otherwise, we will return false. So this timer object, we pass into it how long we want it to run. We have two methods we can access. One is start, we tell it to start running, and the other is complete. We start looking for it to be done, and when it's done, then we're able to do something with it. So to use this timer that we've added, we'll make a timer variable, and this will be our drop timer for how frequently we want the drops to fall. And to do that, we can just simply say drop timer is going to be equal to a new timer, and then we have to tell it what number we want. So it's a good idea whenever we're passing these values in, using things more than once. Like right here, I have 100, 100, 100. Probably need to store that in a variable because as we modify or adjust our game, we don't want to have to remember all the places to change it so we don't break our code. Because if I'd say, oh, I want it to be 50 drops, not 100, and don't change those two 100s there, it's going to break my program. So we're going to look at doing some improvements, some refactoring to our code to make it a little bit better. So our drop timer will just start out right here. And chances are we're going to need to store that value, that 200. That's 200 milliseconds, so 0.2 seconds. And now we can say drop timer dot start. So we can tell the timer to start going. Now if we run our sketch, nothing's going to happen because we're not checking for what is happening. Now, before we can really see the magic of what this timer is doing, we need to do a little bit more refactoring, changing around these hundreds, but we don't want to start out with all the drops falling at once. We only want one drop to fall, and then when the timer kicks off and says, hey, I'm done, then let's have another one. And then we could have another one. Then we could have another one, and we do it sequentially like that. So we need to start out and say how many drops are actually active inside our program. So to that end, we need to set up some values here. So I am going to make a couple of new variables here. So I'll put an extra return here so we can see it. So int, we're going to have our total number of drops. We'll have an int that represents our drop interval. And we'll have an int that is how many drops are currently active. So with that, now I'm putting it here because we're going to need some of these things here. So our number of drops, let's go put that in. We'll start out, that's 100. Well, the number of drops right here, drops is equal to that, so it should really be num drops. And then we cycle through. And again, when we're doing this for loop, num drops as well. Now if we go down into our draw statement, num drops, and by doing this, what it means is if I just change this right here, so let's run this, make sure there's no errors. Okay, no errors, that's good. Now if I just change this to 10 and run it, the program still works. So that's the beauty of doing it this way, is I can change it in one place instead of having to remember all the places where I'm referencing how many drops are being used in my program. The next thing that I want to do, now that I defined out num drops, is I can say my active drops will start out at 0. So we'll start out, there's no drops going on. And let's set our drop interval. And we'll set that equal to 200 milliseconds. So right away we know we can go and change that drop interval value in there. And once again, run it. No errors because, well, we told the timer to start, but we're not doing anything else. So now comes the part where we need to do some management here. This is where we get to update things. So inside of draw, I'm going to just get rid of these lines now because they've been sitting here long enough. I think we've moved beyond what they are. So we can update the catcher. Now, we're going to do a little work with timer management. It's not the same as anger management. We're just trying to organize our time. So what we need to find out is if drop timer is complete. So if drop timer is complete, so we can say true like this, but it's because calling the method drop timer complete returns true or false. We don't really need to say double equal sign true here, but we can. But we don't have to. But if it makes you feel good in there, then that's fine. No, it's going to complain about that in your code if you use a more verbose way of doing that. So now if the drop timer is done, what we need to do is tell the drop timer to start again. Now, what we can do to see that something is happening here is I'm just going to print out a statement here so we'll see something down at the bottom. Now, if we watch in the console at the bottom when it's running, we can see how it progressively put in drop, 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 drop. Now, if we wanted to see it a little bit slower, like once every second, we use 1,000. 1,000 milliseconds, that's 1 second. So now if I run it, we'll see it says drop, drop. So every second, it's specifying that value. So we know that this is working, so we don't need to keep saying that anymore. But what we need to do is we need to manage it. So instead of telling all of the drops to show, so we're going into the drops for loop here. So instead of telling all of them, we want them to update and display. We only want to tell our active drops to do it. Now if I run this, oh no, there's no drops falling because after drops is 0, so it's not going to go. So what we want to have happen is when the timer is done, we need to, instead of printing out that statement, when the timer is complete, and I always like to do it before, not like right after. So I prefer to do it right here before we tell the timer to restart. What we can do is we can say active drops plus plus, just like that. Now if I run this, we'll see they're now coming out in a significantly more controlled manner. So this looks pretty good. But if we keep going here for a little while, we're going to see that problem will happen. Now it's 100 drops, so it's going to take a little while for that problem to happen. But what's happened? Oh, look at that. And that looks kind of bad with all that red on screen. But it gave us an error message that makes sense. And that error message is array index out of bounds exception 100. Well, what happened is we tried to access something in the 101st spot in the array. So once active drops became equal to 100, remembering that we start counting at 0, so 0 through 99 are all valid numbers we can use to access things in the drops array. But when we hit 100, that's asking for something that doesn't exist. And that's what this particular error message means, is we tried to access something that is outside the bounds. So we tried to access something beyond what is available in the array. So we need to couch this statement. Instead of just automatically increasing it, we can say if active drops is less than our number of drops. And again, now you'll hopefully see that there is a lot of value in storing this as a number or as a variable instead of hand coding in 100, 100, 100, 100 or 10, 10, 10, 10, because we can change it in one place and our code won't break. So now I'm going to cut that from there, paste that in there, auto format. So we only increase active drops. Now, to verify this is working a little bit quicker, we'll just go to 10. Now we're on 2, 3, 4, 5, 6. And now we have 10 drops. And they're falling in a much better manner. So whether we have 10 drops, 100 drops, or 1,000 drops, they're all behaving now. And that's what we're looking for by using the timer to control the growth of active drops. Now, if I want the drops to appear on screen but a little bit faster, well, then I could reduce this drop interval down to 100 milliseconds. And if we do that, we'll see that the drops showed up on screen quite a bit faster. Now, again, if we go back to our 100 drops, we'll see that it really does start to fill the screen, but it's better than when they all dropped in one giant wave. This looks much more interesting and natural at that. Now that we have the drops falling, we have the catcher object moving, it's all moving or behaving quite nicely, what we need to do is figure out what we can do to calculate when two round bodies or objects intersect each other. And what I have here is a visual representation of how we will be detecting or figuring out when those two objects are intersecting. So in this instance, I have circles. Each one is 100 pixels wide. So the sum of their half widths would be 50 for each circle, so that's 100. So when the distance between their circles, or between their centers, so we can see right now they're almost touching, and that distance between centers is 104. As soon as they touch, they're intersecting. So when the distance is 99 or less, so we can see how they have to be touching for the intersection to occur. So what we're doing is we calculate the distance between the center of each circle, and we can see the little line helping to give us that visual aid in each circle. And when the distance between their centers is less than the sum of the half width of each object, they're now intersecting. And that is the magic that we are going to use to find out when the catcher has caught a drop. So back in our primary code, we're going to create another method because just makes sense to separate this out into its own function. Now, for that matter, we could even create a collision class that would then handle collisions or intersections between round objects, rectangular objects, and work with that, because when we rewrite the catcher game and are using images, we will very likely be then using box or rectangle collision instead of using circle-based overlap or intersection or collision. All of those words are kind of interchangeable in this regard. But if you're ever looking for how do I calculate what's happening here, collision detection is the term you would be searching for online. So I'm going to create a method that returns a Boolean, and it's going to accept two objects. I'm going to pass into it the catcher and a drop object. Whoop, I need catcher, we'll just call it C, and then drop D here. So I'm passing those values in. Now we get the red line here because it's waiting for us to do a return. So the first thing we have to do is calculate the distance between those objects. And the good part is processing saves us from having to do the trigonometry. And we can just simply say dist, and now we say the distance between 2 points. So I'll say c dot x comma c dot y, and then d dot x comma d dot y. So we have the x and y of the catcher, the x and y of the drop. So we're saying what is the distance between those two objects? And then we can say if the distance is less than the sum of the catcher's width divided by 2 plus the drop's width divided by 2. So again, half the width of each object, remembering that visual that we had with the two circles. So if the distance is less than the sum of the half widths, we return true. Else, we return false. Simple as that. So we return true or we return false. So to put this into practice, what we want to do is inside, well, we're looping over the droops, looping over the drops. We want to check for collisions. And we do that by saying if intersect of the catcher, oh, and it's C, not spelled out catcher, whoops, my bad. So if the intersect of the catcher and then the current drop that we're putting on screen, so if that intersect returns true, and we can even do like this if you want. So if that returns true, at this point, we need to tell the drop that we're in reference to here that it's been caught. Now we see it underlined because it says the function caught does not exist. And that is 100% true because inside the drop, we haven't made it yet. So what I can do at this point is make that method inside the drop class, and I can simply say speed y is equal to 0. Now if we run our program again and start catching drops, you'll see how it freezes them on the screen. So I am catching the drops. So there's a lot of things that we could do with this. So when the drop is caught, we could set their speed there. We could also change color here. So when they're caught, so instead of making them red, we could now make them turn blue when they get caught. we get a visual representation so we can see, hey, look, I caught those drops. Now, we could do that. We could also put them at the top of the screen. So there's a lot of things that we could do. So we could make it so we can see how they're going away. So if we want them to stay on screen, we could put them off screen. Number of different possibilities here as to how we want to handle it. We could make it that their speed doesn't go away. Maybe they change color or they change size so they become smaller each time so they're harder to catch. There's lots of options that we can explore. So it's going to be up to you to figure out how to turn this into something that you have customized and made enjoyable to play.